Recording's rolling. It's Wednesday, October 15th. We're on lesson 38 on page 189. This is solving linear and nonlinear systems. So you guys know linear is just a straight line. Nonlinear, well, there have been parabolas all through this module. And so a really good visual example, or actually example I'm going to do with you guys. That's on the next page right here. Type 3. You guys see this blue parabola and this straight orange line that goes through it. Now, there's two places where they cross, and those would be the solutions. So if you say that where the solution of that system of equations. Well, there's an answer there, and there's also an answer there. So they cross. So I'll do that one with you guys. Okay, so keep in mind, you guys know that Alex assignment 362738 is due Friday. Okay? So yeah, and we're coming for each day. This will be the very last lesson of module 3. So I'll solve one of these examples with you guys, and then rest of the class walk around, help you guys out. So any questions you guys have? Also keep in mind that your next pi goal isn't due for a couple of months here, so December 12th. That's your 50% pi goal. That'll lead into the midterms. There is a quiz on Friday. So tomorrow I'll do a module 3 review with you guys, which is just parabolas all over the place, right? So I'll do that here. And then quiz on Friday. All right, so let's look at one of these. Now, what I really like about example 3 is that they give you system equations to solve. Here, I can hold this closer. Here. And then no, it doesn't. I tried many times, so yeah, this is the best I can do. Yeah. You can hold it closer. You can you can type that into Desmos. Right, so on the main recording that I uploaded, there I used Desmos a few times, so you can always type the equations in and look on Desmos and see like that, right? So let's see where those two equations cross. So the system of equations goes y equals x squared minus 2x plus 6, and y equals 4x plus 1. Okay. So I just copy that straight out of the book. Right? That's the system. Okay. And from the graph they give you, I see exactly where those two graphs cross. This is the point 0, 5. This is the point 5, 21. So I'll go ahead and write the answer up here. So 0, 5, and also 5, 21. Okay, something like that. Okay. So I know the answer. I'm just kind of work towards that. So one way to solve is with a graph. You get graph these and just see where they cross. Or you can use substitution or elimination. How about this? I'll do a substitution version. If y is equal to this, y is also equal to this. Okay, I just set those equal to each other and solve for x. So I can say x squared minus 2x plus 6. That's the first equation. Okay. What if that is equal to this straight line, 4x plus 1? Wow. And then I can solve for x. So, I got an x squared and x a constant. I know this is headed towards either the quadratic formula or factoring somewhere down the line. So I need to set this all equal to 0. Hasn't that been the method over and over? Set equal to 0. So minus 4x and minus 1. So I'm going to subtract the 4x and the 1 from both sides to get it set equal to 0. Gives me x squared minus 6x plus 5. Here's that. Okay. Now, from here, I do see that this is factorable. And if it wasn't easily factorable, or if you weren't sure how to factor it, you could use quadratic equation. So here, I'll split the paper and show you guys. At least I'll set up 2 different methods of doing it. So you could go x equals negative b. Guys, what is negative 6? Yeah, positive 6. Yeah, plus minus square root of b squared minus 4. A is 1, C is 5. Okay. This is all divided by 2a. Like that. Right. And so you get 2 answers that way with quadratic equation. Or you might see that actually this is pretty straightforward factorable. Guys, give us the x minus 1, x minus 5. Because I can check my work by foiling. Let's do FOIL. FOIL. First, x squared. Bing. Outside, inside, it's negative 5x, negative x, negative 6x. Bing. You guys, what is negative 1 times negative 5? Positive 5. Bing. Okay. Now, since this times this is equal to 0, that means if either piece of 0, the whole thing is 0. So for that, you can get, guys, what could x be from just this part right here? X could be what? Guys, what minus 1 is equal to 0? 1. And from this right here, x could be what? 5. Because 5 minus 5 is 0. That would 0 the whole thing also, okay? Now, those are x values. If you want the full coordinate, I still have to plug it back into either one of these equations to get the y value, the corresponding y value, right? And they both tell me the same thing because I'm finding where they cross. So how about this line? I think that's a little easier, right? So 4 times x plus 1. So guys, what is 4 times 1 plus 1? What is that? 5. Okay. And then for the y value, that's like y equals 5. And then over here, y equals 4 times 5. There's this 5 right here, plus 1. What is that? 21. Right? So put it all together. If x is 1, y is 5, you can think of that like a coordinate, could you, on a Cartesian plane? And if x, what's that, and if x is 5, y is 21, that's another coordinate where those two ground cross. Okay. So print those 2 points for original solution. In fact, that's exactly what I wrote in thinking at the beginning. Because that's what I got off the graph. Here, show you guys the graph one more time. Okay. So I'm putting in 1, 5, and 521 is where they'll cross. Yeah, there's 1, 5, and there's 521. Exactly. And so the puzzles throughout this particular lesson are all pretty much like that, just over and over and over. I mean, there's a few little twists, like here we got like a sideways problem, so that's so fun. There's of course some word puzzles. You guys bet. Here, I'll show you guys at least one word puzzle I thought was kind of intriguing. Was a road. Guys, is a road perfectly flat? No, you don't want it to be perfectly flat. Because if it is, just naturally it'll get like little bumps in it, and then when it rains, you think all that rainwater would just puddle, and that would be dangerous, wouldn't it? You don't want to drive a road with puddles in it. So what they do is they actually curve the road. It's actually a very shallow parabola, and they give you the equation right here. Look at that. It's 1 over 300 x squared. So it's a very shallow parabola. So when it rains, the rainwater just runs off. Now, you're saying, what if there's a flash flood and the water starts to rise? Like, how much of the road would be left? Oh, well, that could be a linear equation, the height of the water. And if the road's on a parabola, very shallow parabola. Right? So, again, you can use system equations, just like the example I just did with you guys. Yeah, it's all there. Okay. So, some of you guys were asking me questions as you were walking in, so I said I'd walk around and help you guys out. So, there you go. So, you guys can either watch the video I uploaded, or you can work with Alex, and I will walk around and help you out.